Hi, everybody. Today is Sunday, August 14th. I am man drinking coffee, looking at computer, and today we're going to work on some more exercises. The two concepts we have today in the Elixir track are the pattern matching and tuples. Pattern matching probably being one of my more exciting ones. The use of pattern matching is dominant in assertive idiomatic Elixir code. You might recall that equals to is described as a match operator rather than as an assignment operator. When using the match operator, if the pattern on the left matches the right, any variables on the left are bound and the value on the right side is returned. A match error is raised if there is no match. So in this case, basically, you've got 2 equals 2, and that returns a value of 2. If you try 2 equals 3, there's a match error because the value 3 cannot go into the value of 2 because there's a conflict there. And when you have a variable name on the left side, that will, capture or bind the value from the right side. So in this case, float ratio will return probably okay, and then the value. And so, or no, it's a float ratio. Okay, denominator. So it'll return 1, 4. Denominator will then be bound to the value of 4. Remember, matches occur from the right side to the left side. In the last example, if we don't need a variable in a pattern match, we can discard it by referencing the underscore character. Any variable starting with underscore is not tracked by the runtime. Pattern matching in named functions. So pattern matching is also a useful tool when creating multiple function clauses. Pattern matching can be used on the function's arguments which then determines which function clause to invoke, starting from top of the file down until the first match. Variables may be bound in a function head and used in the function body. So here we're going to declare multiple implementations to our function. So in this case, we have 2 functions called named function. They both take in a single argument, and in the first one, there is a pattern match to the atom A. In the second one, there is a pattern match to the atom B, and depending on which one you call, that'll be the one that you get. And you can see here in the third example, they tried to call named function with a value for atom C, and they got a function clause error because there was no named function that could accommodate that pattern match. But cool, so that's pattern matching, and you'll see a ton of that as you get more into Elixir. Next up, we'll talk about tuples. In Elixir, a tuple is a data structure which organizes data holding a fixed number of items of any type, but without explicit names for each element. Tuples are often used in Elixir for memory read-intensive operations, since read access of an element is a constant time operation. They are not usually used when elements may need to be added or removed dynamically, because rather than modifying the existing tuple, a new tuple is created which requires memory to be allocated up front. In practice, tuples are created in Elixir using curly braces. Elements in a tuple can be individually accessed using elm\2 function or using zero-based indexing. So yeah, tuples. So here we have our example. We're going to create an empty tuple with 2 curly braces and no values. We'll create a 1-element tuple by putting the integer value of 1 inside of curly braces, and you'll get multiple element tuples where you've got an integer value 1, an atom of A, a string of hello, all contained within braces, and that's multiple element tuple. If you want to access the value inside of a tuple, you can use Elm, where you pass in the tuple, you pass in the number that you want for the index, in this case 2. So start with a zero-based indexing, 0, 1, 2, you'll get the string, hello. Tuples are grouped information. Tuples are often used in practice to represent grouped information. Float ratio for 0.25 returns 1, 4, indicating the number and denominator of the fraction. So you'll see tuples all over the place. Often, a lot of times when you call a function that can have a successful path or an error-filled path, you will get like an OK tuple where the first element of the tuple is atom OK or atom error, and you can kind of use that to kind of distinguish like, was this function successful or not. And so you'll see that pattern all over the place within Elixir. All right, so with that said, we're going to start working on Kitchen Calculator. We'll read the very beginning of the instructions here. When preparing to bake cookies for your friends, you have found that you have to convert some of the measurements used in the recipe. Being only familiar with the metric system, you need to come up with a way to convert common US baking measurements to milliliters, ml. For your own ease, use this conversion chart for your solution. All right. We're going to copy this, and we're going to go timestamps. Show timestamps. Show the time and date it preferred when each line was last modified. Okay. View. Interesting. Yeah, I am playing with iTerm 2. I've never used that before. And I turned on the tips. I didn't turn it on, I left them on. It's because I'm trying to get a little bit into it. Alright, so let's go into our example here. And big. And let's see, we'll get the library up. We'll get the test file up. And we want test file there, and then we'll get the README up on a third pane. And yeah, it should be good. All right. So we went over tuples, we went over pattern matching, and now we are into the example. So, number 1, get the numeric component from a volume pair. Implement kitchen calculator.getVolume \1. Given a volume pair tuple, it should return just the numeric component. So if you are given cup 2.0, you would just return 2.0. Okay, so we can use the element function for that. Volume pair, and we'll just return 1. And we test or at cursor in our describe block, and those look good. I will say, like off the top of my head, like you're making an assumption here that this is a tuple that has 2 elements. You could fix that. You could be more protective through dialyzer and maybe even where clause. Do kernel. No. Try and do a. Oh, I don't have my Elixir lang. I don't have my docs bookmarked like I expect them to be. Normally, historically, on my old laptop, I would just type kernel and it would just come up. But all right, let's see here. Let's see if we can do guard. Patterns and guards. What I'm looking for is well, let's see here. So elements in the kernel. Is there a tuple module? Put element, tuple size. Yeah, there you go. I wonder if you could do a thing where it's like when tuple size equals 2, and instead of that hard-coded one, we'll say volume pair. Let's rerun the test just to see. So that'll still work. So let's say we're checking for 3, which we're not, but I just want to see what the error is. Yeah, so it'll fail because the guard fails. So yeah, that's like one way you could be a little bit more explicit. So we'll leave that in there for fun. All right, number 2, convert the volume pair to milliliters. Implement kitchen calculator.2 milliliters function given a volume pair tuple. It should convert the volume to milliliters using the conversion chart. Use multiple function clauses and pattern matching to create the function for each unit. All right, cool. So we're gonna have to do multiple ones here. So the fluid ounces. Yeah, I was gonna say what are the atoms? So the first one is cup, and let's call volume. We'll get rid of that. So we're gonna have multiple implementations of this. At least one more. So the second one is going to be fluid ounce. Third one is going to be teaspoon. This is going to be tablespoon. And this is going to be milliliter. And in the conversion chart, so 1 over. So basically, this is volume times. So 1 cup is 240 milliliters, and then 1 fluid ounce is 30. Teaspoon is 5. Tablespoon is 15. And milliliters should just be the original volume. All right, so let's test at cursor. And oh, it expects the it expects to get back a pair. All right, so let's see if we can use multiple cursor here. milliliter, comma. All right, cool. And then that should close. Oh, forgot this one. Oh, we didn't do that yet. Cool. All right, cool. So those pass, and they look good. It's a little smaller. Alrighty, number 3. Convert the milliliter volume pair to another unit. Implement kitchen calculator from milliliter function given a volume pair tuple and the desired unit. It should convert the volume to the desired unit using the conversion chart. So say milliliter, that, return cup, 5.5. Okay. So what does this look like? From volume pair to unit. Use multiple function clauses. Okay, so this is going to be somewhat similar. So the first one will be cup, and then the other ones will be the different ones. Okay, so cup, again, fluid ounces, teaspoon, tablespoon, milliliter. Alrighty, any unit to any unit. I'm thinking, just to show you what I'm thinking. I mean, the thing we need to return here is like, you know, cup value or new volume. I'll just say volume. And of course, to get the volume, I'll have to say volume. I want it in like volume in milliliters. And to do that, I would call, the volume pair, whatever the incoming, volume pair was, would get it in milliliters. So that way I knew. And then for like cup, it would be volume divided by 30. Maybe. Let's try that just to see what this looks like. Yeah, so this test is the one of the ones that's doing it. So that failed. Bad argument in an arithmetic expression. I don't want. Alright, yeah, I don't want the entirety of this. So 2 millimeters will always return milliliter. Atom, I just want the volume, so I'm gonna use pattern matching. To pattern match it into a tuple, and I'm gonna ignore the first value, and I will capture the second value. And we'll see how that works. Cool. So this expected the left was 28. Oh, it's 240. See, this is getting to my point. I mean, the thing I'm trying to figure out is how do I want to dry up the logic of this conversion. Let's just let's just get it working, and then we can look into improving it with a refactor after we get the test working. And this will be 15. And this should be easy. This should just be the volume pair, right? All right, let's test all of these. Test at cursor, and we got some failures. What do we got here? Some of them worked. Expected fluid ounces. Oh, that's because I copied the word cup over and over and over again. All right, let's do this. Teaspoon, tablespoon. All right, now let's try it. All right, that looks good. All right, yeah, let's keep moving, and then we'll come back to refactor that. Convert from any unit to any unit. Implement kitchen.calculator convert function given a volume pair tuple and the desired unit. It should be able to convert the given volume to the desired unit. Okay. Yeah, this is just gonna call from volume pair to unit. Oh, this is just gonna call from to. So we'll say well, the first thing we'll do is we'll convert it to milliliters. So that'll just be volume pair and whatever the volume pair unit was. So element volume pair, and that would just be the 0 element. What are you complaining about? Undefined function to milliliter. See, if I could only spell, I would be dangerous. Oh, I need the module name there. Now it's going to complain. Is undefined or private? Oh, I don't even need that. I just need, yeah, just one argument. Okay, so that's going to be the milliliter value. Let's say this is the milliliter volume pair. So now that you have it in milliliter, now you can say 2 unit. Why am I not thinking of this right? So given a teaspoon, give it to me in tablespoon. Oh, you went from. Yeah, the naming is getting me. Then you went from milliliter, and so you'll hand in the milliliter volume pair, which is always in milliliter, and then you'll pass in the unit. I think that'll. Let's test that cursor. Cool. It looks good. We'll test all in file. Cool. So we've got 19 tests and we've got 0 failures. So this looks like it's working. Now the thing I don't like about where we stand right now is the was there any other guards that we want to add? Compare. We could probably add that to those as well, just to be, you know, specific. We'll add there. Run the test one more time. All right. That's not my real issue. My real issue is these values, these 240, 300 thing. I don't like that. You know, we're repeating these values all over the place. So I'm trying to think of the best way to. What is the best way to keep that dry? I mean, you can create. I mean, you could create a function or something like define private. I don't want to say the word convert. Volume conversion. I don't even really particularly like that. And so it would take in a volume value and then a unit. I don't know. Volume in milliliters, 530, 240. I'm going to leave it for now. I anticipate that when we look at the community solutions, we'll probably see some interesting choices there. So let's just do that. Let's Exercism, submit, lib, kitchen calculator, and we'll open it and take a peek. Our iteration has passed. It looks good. Let's take a look at the community solutions. Yeah, so this is a good one. So they created a ratios map. We haven't really learned maps yet. But they store the ratio there, which I like that. That's good. And they're also using pipes to do that, which I thought of, but I kind of pulled back from because we haven't technically learned pipes yet. But yeah, I do like that ratios module attribute. That's good stuff. Anybody else have any? I mean, I guess the one way you could do that, you could build a ratio. If you want to solve this without using a map, one way you could do that is by using a define p ratio, and then it would just take the unit. So let's get the units up here again. So let's see here. We've got ratio cup, and for this one we'll do it as we'll just do it inline as like not inline, but as a one-liner. So let's see here. So that's 240, and then these other ones are going to be fluid ounces, teaspoon, tablespoon, and milliliter. And then the ratios are going to be 240, fluid ounces is going to be 30, teaspoon is going to be 5, tablespoon is going to be 15, and milliliters to milliliters ratio is going to be 1. Cool. So now, whenever we want the ratio, we can say ratio cup, and then ratio fluid ounce, ratio teaspoon, ratio tablespoon, and then we don't have to do a ratio here because it's going to be 1-to-1. Although, and this is, I mean, so right now the ratio for milliliter, I mean, it's not, it's never going to change. We'll times it by that. Even though we, like, at the time of writing this, of course, we know that this is 1-to-1 milliliter. But if you're going to get the other values for this ratio private function, then you probably should do that too. So let us run the test and make sure that we've done this right. So do we need doing this wrong? I thought it was just, oh, I have an extra n there. Yeah, the comma's right. Yeah. Alright, cool. So this looks to be working. So now what we're going to do is we're going to finish getting this right. So volume divided by ratio cup divided by ratio fluid ounce divided by ratio teaspoon divided by ratio tablespoon. And then This one just returned volume. This just returned the volume pair. I'm gonna do it like this one. So instead, what we'll say is milliliter. We kind of know it's milliliter because I'll do it like this. This looks a little weird because it's like it's doing work that it doesn't have to, but I'd almost rather, I don't know. It would feel weird not to make this like an assumed value, like a hard-coded understanding that it's 1. I think what I would happen is I'd prefer to do it using this new ratio private function. And then if it was observed in production that it's a production, like it's a performance issue, then I'd come in and remove that and hard code the value. But with that hard code, I'd add like a comment in line that says like, that is why I'm doing this. All right, cool. So that looks good. Let's resubmit. And let's go to exercises. Oh, we want to go to kitchen calculator. We have 2 iterations now. Iteration 2 is passed. Looks good. We'll mark it as complete. We will publish our solution. And cool. So we've completed kitchen calculator. We've learned 2 new concepts, pattern matching and tuples, and we've unlocked 5 new concepts: maps, module attributes, which as constants, piper operators, recursion, and strings. Wow, we're starting to get into some cool stuff. And then a bunch of exercises. So cool. All right. Yeah. Next time we'll get into probably pipe operator, and yeah, that'll cover a couple different. So pipe operator, a high school sweetheart. So that'll be strings, and the pipe operator will probably be the next one up. Until then, thanks a lot for watching. I hope you enjoyed yourself. If you have questions or feedback, definitely let me know. And I will see you next time. Bye-bye.